One of the unique features of Safran Risk is the ability to create risks, load schedules, and run a highly detailed risk analysis all down to the individual minute level. Here you can see an example of a railway maintenance project where this is of particular importance. Now, before we look at the schedule in more detail, I want to talk a little bit about the user interface we have in Safran Risk. At the top you can see we have a number of tabs. These are here to help guide you through the analysis process. At the center of the screen we have the green Analyze tab. To the left we have our risk inputs, and to the right we have our risk outputs. Okay, let's get back to the schedule. As you can see, I already have one opened, but all we need to do if we want to bring one in from a variety of different sources is if we go to the File Import menu, we can import projects from a variety of sources, including Microsoft Project and Primavera XCR files. The example we can see was imported from an XCR file scheduled in minutes. Because Safran natively deals with all your schedule and risk data to the minute, it can save you not only significant time and effort trying to manipulate the schedule to match, but perhaps more importantly, improves accuracy and reduces the likelihood of any errors. In the view we have here, you can see the Safran dates in the kind of bluey color columns, and also the in this case the Primavera dates. Now, to save you having to work out what any differences might be, we have a difference column, and as you can see in this case there are no differences. We can see 0 in all the difference columns for all the activities in the schedule. Another great feature about this particular view is we actually have some bars drawn underneath the bars in Safran to show you where P6 has scheduled all these activities, and here you can see as you would expect there is no difference, but it highlights them for you immediately and also means you don't have to manipulate any of the activities individually. As well as making it clear where any potential differences may lie with the schedule that comes in, Safran is also constantly monitoring the schedule for any possible problems from a risk analysis perspective. It does this in the Schedule Warnings tab. So as we add, maintain, import the schedule, it's constantly keeping an eye on any potential problems. These typically include constraints where something such as a hard finish on constraint might stop the risk model from moving around. In the example here, you can see that we have our continue bolt excavation has a constrained activity with a must finish on constraint. Now, in order to have a look at that, we can simply click on the activity and it takes us straight to the one in question, and in this case I'm going to just remove that finish on constraint. Now, as soon as I've done that and I click back to Schedule Warnings, you'll see it's reassessed the whole schedule and removed that constraint. So we know we're good to go now from a risk perspective. Let's move on and look at how you create project risks in Safran. So a project risk has a name, in this case productivity, a description, it has an impact. These are either standard or calendar. We'll focus on standard here. A probability of occurring, 100% is typically used to denote an uncertainty. And then impacts. This particular productivity risk has a schedule impact, and it's a relative type of impact in the range of 95 to 105%. So this means it'll impact any activities it's assigned in that range. We also have absolute impacts. So this wind speed affects works actually also has a schedule impact, but this time it's an absolute impact and it uses a uniform distribution. Here are our various distribution shapes we support. And it's in the range of 1 hour to 4 hours. Now, because we not only schedule down to the minute, but we can also provide risk information down to the minute, it's possible to say the maximum impact of this is, for example, 4 hours and 10 minutes. So we can be very precise about the level of detail we go down to. Now that we have our schedule and we have our project risks, we can move on to mapping those risks to the schedule. We do that in the Risk Mappings tab. Here you can see on the left hand side we have a view of our schedule. Across the top you can see all the project risks that we've just created. Now some of these projects might contain many activities. In fact, this one has well over 1,200 activities. So a useful feature in Safran is to be able to filter that list down to a manageable chunk. To do that, we can go into our schedule and we can look at our filters. And if we go back to our mappings, we simply select any of the filters that we've already created, or we can go and create a new one. In this case, I'm going to filter down to just look at the signalling activities on this particular project. Now, Safran Risk allows you to actually filter any filters that are applied here will actually apply across the whole of the product. So that will include the schedule tab and also all of the results when we come on to look at those. So now we're just going to focus on one particular area of the WBS. And this can be driven from any codes you might have brought in from, for example, Primavera. Now, because again you might have large schedules, Safran Risk allows you to allocate risks either in a sort of top-down approach or a bottom-up. So, for example, I could say, let's say external incidents as a risk. I can say very easily that this could apply to my whole signaling WBS. Or perhaps it only applies to changeover location. Because it's very easy to either apply to a group of activities or just a single activity. Now you may have noticed something happening here on the right hand side. At the top we actually have a list of the risks that are assigned to each activity. So you can see as I assigned external incidents to changeover location, that risk appeared here on the right hand side. And what you can also see is our real-time analyzer at the bottom. Now this allows you to gauge whether the assignments that you're making are in the range you'd expect, and it does that by running an automatic simulation of the project or of this particular activity. So you can see as I add more assignments, more risk assignments to the activity, the range here is changing. Now it's the deterministic value was just 1 day, and here you can see now it's in the range of 1 day all the way up to 1 day, 9 hours and 21 minutes. So again, it lets you gauge whether it's realistic, the assignments that you're making. Now we're ready to actually run our first risk analysis. We'll switch to the Analyze tab and we're going to simulate the project running 250 times. In this particular case, each time it will select values from the distributions that we've assigned. Now it's finished running, and here we can see the results for the overall project finish date. We can see here that the deterministic finish was the 31st of December at 0500, but based on the confidence level that we provided, which is the P95, the finish date is expected to be the 31st of the 12th at 0900. So based on that, we have a 4-hour contingency window to work with. We can also see the probability of actually finishing on our deterministic date and time is only actually 9% likely based on the risks we have assigned. We can also see any of those values for individual activities in the schedule, as well as just the overall project. So here we can see the likelihood that we'll actually finish the correspondence of track circuits around points at the given deterministic value that's provided in the schedule. This is all very useful information, but what it doesn't tell us is exactly what's causing the delays or the potential delays to our project. So for that, let's look at the drivers. Now here we can see on the left hand side, we can see the risks that are driving any delay to the potential project finish date or indeed cost. And on the right hand side, we can see those activities that are driving the project, the potential project delay. Now, if we take a mental note here that line possession late is actually the risk that's most likely to delay our project, I'm going to move on and show you something a little bit more interesting, because what this is telling us is which risks are driving the project, but it doesn't actually tell us by how much. So for that, we need to switch over to our sensitivity analysis. Now, what the sensitivity analysis is doing is it's using a technique called risk by exclusion, and it's actually rerunning the entire analysis, and each time it's going to deselect one of the risks from the analysis. That allows us to actually look at precisely the amount of delay each risk is actually causing us. So here we can see as the analysis starts to build up, line possession late, for example, is causing us a 39-minute delay. So if we were to mitigate that risk fully, we would save ourselves, in this particular case, 39 minutes. Now, what's so interesting about this is that line possession late was actually showing as our top risk driver in the driver's report, which is typical across many other products. But we can see here already, and it's finished running now, that in actual fact, the PM-LEM breakdown is actually causing us over 3 hours worth of delay. So to fully mitigate that risk will save us significantly more than line possession late, despite the fact that line possession late is actually shown as one of our top drivers. Now, let's look at the impact of modifying one of the maximum ranges of one of these risks by just a small value. Something else that again isn't possible in other products. So if you remember the overall project finish date, we had a contingency window of precisely 4 hours. Now I'm going to just switch across the project risks. I'm going to select my PM-LEM activity, and I'm going to increase the maximum range up to 2 hours and 13 minutes. So this is just the range. This isn't actually saying it's going to add 13 minutes to everything. It's purely the selectable range that the risk analysis will choose from when it's running. Now I'm going to rerun the analysis again, just another 250 simulations of it running, and let's see what impact just adding those 13 minutes has. Okay, so we can now see that just adding 13 minutes onto one particular maximum range has actually modified our contingency up to 4 hours and 18 minutes. Now, the PM-LEM actually isn't assigned to many activities, so you can imagine if this risk was assigned to multiple, then that impact, that 18 minutes, would grow significantly. So by not being able to model risks down to the individual minute level, you're losing that level of power.